Hey guys, Miss Pinnell here. We are going to do 3.1 lines and angles. This is going to be the last section of it. I posted the notes outline to my website as well as OnCourse. So you are, feel free to print this out and follow along on the notes page. If you can't print, that's okay. Just write it on a piece of paper. All right, so this is what we're gonna do. I am going to get started and we're going to cover everything from section 1, and then I will give you an assignment so you can practice some of these materials. So it is 3.1. If you need to refer to the book, it is the same section. So chapter 3, section 1. All right, let's go ahead and talk about parallel lines. So the first thing I want you to notice is that parallel lines are coplanar. That means, if we redefine this, coplanar means they lie on the same plane. Coplanar. In order to be parallel lines, they must be coplanar. The only difference with this is that they never intersect. So you will never see them touch each other. The arrows are used to indicate these lines are parallel, and I'm going to show you using these two lines here. So we have line AB and we have line CD. And they are indicated that they are parallel if you were to draw these arrows here. Okay? That means that those lines are parallel. The other thing I want you to see is that there's a specific notation we use. And the notation is listed as, I'm just putting it in parentheses, 2 lines up and down next to each other. Okay? So if we have line AB and line CD and we want to say that they're parallel to one another, we're going to note that by writing the line AB. Now remember, line AB always has the arrow above it, is parallel to line CD. So this basically is translated, so let's go ahead and translate this. It says that line AB is parallel to line CD. That means that they will never intersect and they belong on the same plane. That's parallel lines. Okay. Next, I want you to see parallel planes. Parallel planes never intersect as well. The only difference is they're the entire plane, or a brings you right back to school. They're an entire plane instead of just a line segment or a line. So let's go ahead and label these two planes if it isn't already labeled for you. We're going to label the top plane J, and we're going to label the bottom plane K. Okay? Remember, a plane is a two-dimensional figure, 2 dimensions. And there's a specific symbolic notation for parallel planes. So we would basically call this, we're using the same parallel symbol as that. The only difference is we're just using J and K. So we would say plane J is parallel to plane K. And that ends our parallel planes. All right, let's advance this a little bit and then talk about skew lines. So skew lines are non-coplanar. So that means they do not belong on the same plane or lie on the same plane. So they do not, there's a difference here, lie on the same plane. And again, they will never intersect. So let's get some examples of what a skew line looks like. So if we look at this figure, we'll notice that this figure is a cube. Okay, and we have a lot of lines here. So let's go ahead and find some skew lines, okay? So let's start with PS right here, this line here, PS here. So we're gonna say, let's look at PS, the line PS, and let's find a skew line in order of PS. So a skew line could be a lot, but we're going to specifically say that PS would be skewed with VR here. VR. And what you'll see is that PS and VR are not on the same plane and they will never intersect. Let's go ahead and look at another one. Let's look at TW, and I'm going to use a different color marker, a little purple one here. Let's say TW is skewed with UQ. UQ, so this one here. They do not lie on the same plane and they will never intersect. So it would be skewed with UQ. Now remember, you could have written that as WT and QU. It doesn't matter because we can write those interchangeably. And let me find one more marker. And we will look at, let's say, line PT for a third example. Line PT. And I'm going to highlight that. So line PT here. And a skewed line to PT would be QR. QR. Okay? So those are an example of our skewed lines. And we're going to have to be able to identify those in a little bit. So let's move on to example 1. And example 1 is we are going to name all the segments parallel to AE. So let's look at AE here. AE. And they want us to find line segments that are parallel. So remember, parallel means that they never intersect, but they are coplanar. So they lie on the same plane and they never intersect. So if you look at this diagram, see if you can list the first one. There are 3. So we'll have 3 that are actually parallel to this. And the next one that's parallel would be BF. BF. So we would write that as BF with a line above it. And if we look for another one, it would be CG. CG. I don't know where I got the Q from. CG. And the third and final one would be DH right here. So now let's give 2 examples of parallel planes. Parallel planes. So let's use a different color. I'm going to use purple. Parallel planes. Remember, a plane is a 2-dimensional figure. So in this case, they give us plane ABF. So let's look at plane ABF, and the way we denote that is by writing plane and then the 3 letters ABF. So it would be this plane here. So be A to B to F, okay? We're overlapping a little bit with the other one, but that's okay. So that's going to be our first plane we'll look at. And that plane is parallel to plane DCG on the other side. So on the other side, it's highlighted or outlined with a dash. It would be that one. So plane DCG. Now the other one would be plane ADH. So ADH. So that's this plane right here. A on the side. ADH, that one there, would be parallel. You can kind of see it, I'm sure, for yourself, but BCG. BCG. This one right here. Okay, so we would just write that as plane BCG. And the last thing they're asking us to do is finding all segments skewed to GH. So let's identify GH real quick. So GH is this top one here, and that's going to be a dark navy. So GH. We're going to find all segments that are skewed within. The first one I notice would be FB. FB right here. This first one here. FB. Another one would be EA. So we'd write that in. The third one is AD. And remember, we're finding skew to GH. So I know I'm drawing the other or outlining the other lines, but that's not what we're comparing it to. We're comparing it to GH here. So we're looking at AD is skewed to GH. It's not skewed to AE or EA here, but that's not what we're comparing to. We're only finding the skew line to GH. Okay? So then another skew line to GH, and the last one would be BC here, okay? So those are just examples of how we would identify a parallel line, parallel plane, and then skew lines. All right, let's go ahead and look at example 2. Example 2 gives you a different figure, and we're gonna name all segments parallel to JK. So parallel to JK. So I'm gonna outline JK with one color, and we're going to identify what would be a parallel line to JK, and there is only one. So if we look at JK, the only parallel line that we see here would be OP, right here. So line OP. Now, let's look at the parallel line to NS. So I'm gonna underline parallel, and then let's go ahead and outline NS. And there are actually a few lines that would be parallel to NS. And the first one we see is right next to it, and that would be MR. So let's go ahead and write MR with a line. The next one, we could keep going down. LQ here is also parallel. Third one would be KP. And the fourth and final one would be JO. JO. Okay, so those are the parallel lines. Let's look at parallel planes. The last one, parallel planes here. So parallel to the plane. First, let's identify what the plane is. The plane would be JKL. So this plane here, JKL, and we would actually identify the entire plane. Now, although it's has multiple sides, it's not just a two-sided figure, it is still two-dimensional, okay? It is still two-dimensional. It's five-sided, which makes that into a pentagon, right? So this figure would be a pentagon because it's 5 sides. However, it is still a two-dimensional figure. The figure as a whole would be three-dimensional because it has length, width, and volume, or height. So that makes it a three-dimensional figure, but it is still, this one side is still a two-dimensional side. Okay, so plane JKL would be parallel to the plane OPQ or PQR. Either way, so I'm just going to highlight that. So those two would be parallel to one another. So we're going to label that as plane PQR. And the fourth and final one, they ask us, what are the 4 segments? What are the 4 segments? I'm going to use yellow. Maybe we can see that a little better than the dark color. So 4 segments that are skew to RQ. So let's look at RQ. Outline RQ here in yellow. And let's find 4 segments that are skewed, meaning they do not lie on the same plane and they are not parallel to one another. So the first one that I notice is this one here, J and O. So we would write J, O. The next one would be JK. JK. Now remember, I'm still comparing it to this one. Every time I write a new outline, I'm still comparing it to RQ. I'm not comparing it to the other ones that I've drawn. The third one is JN. And the fourth one, we can stop there, would be PK. And I'm sure you can find some more, but those are the four that we're going to list right now. Okay, so that finishes up example 2. Now let's talk about a transversal. A transversal, we've seen this before. We've seen it in the 8th grade. So it's not new, but we're going to kind of expand on our knowledge of a transversal. So if we look at a transversal, we notice that this transversal cuts in between two other lines. So it's a line that intersects two or more lines. So if we look at this one, we label it transversal with a T. So you'll notice we label it with a T, okay? So this transversal is intersecting, and we see an intersection here, and we see an intersection here, LM. So we would label this transversal as line T, and that's it. We would label that transversal line T. And if you'll notice, if we just had these two lines, we have no extra angles, right? But because we have a transversal, this line straight through, we have now created multiple angles. So we've created an angle here, an angle here, an angle here, another angle here, an angle here. And let's get a different color. An angle here, here, and the last one would be here. So with that one line intersecting the other two lines, we have created now 8 angles. Now these 8 angles have a relationship with one another, and we're going to look at what that relationship actually is. So let's look at the first one. So if we'll look here, I'm going to identify your transversal. Well, your transversal is labeled with a T. So let's draw a line straight outlining that transversal, right? So this is our transversal. It would be line T equals our transversal. And it created those 8 angles that I identified in the slide before. So let's look at the first transversal. So the first one is going to be called corresponding angles. Let's go ahead and identify all of the corresponding angles. Now, a corresponding angle are angles on the same side. So I'm going to underline that, the same side of the transversal and in the same position, So let's go ahead and look here and see which one would be considered the corresponding angle with lines L and M. Okay, so the first one we can look at is they're on the same side of the transversal and on the same position. So we can look at angle 1 corresponds with angle 5. So angle 1 and angle 5. So the way we would write that is our first example would be angle 1 and angle 5. The next one, I'm going to use a different color to denote this. The next one, let's look at 2. So a corresponding angle with angle 2. So what do you think the corresponding angle to angle 2 would be? So it would be angle 2, and if they're on the same side of the transversal and in the same position, you're right, it would be angle 6. So angle 2 and angle 6. Let's identify another one. Let's look at angle 4. Angle 4 here, it's kind of this yellowish color. So if we look at angle 4, what would be the corresponding angle to angle 4? Well, it's on the same side of the transversal, and it's in the same position in line with that line, so the corresponding angle would be angle 8. And the fourth and final one, let's go ahead and look at angle 3 here. So angle 3 would correspond with angle 7. Angle 7. So those would be considered corresponding angles. Doesn't make them congruent, it makes them corresponding. Okay, so that's kind of the first angle pair relationship that we have. The next one I want us to look at is alternate interior angles. Alternate interior angles. So I'm going to highlight alternate interior here. And that's the one we're going to look at next. So let's identify our transversal. Our transversal is labeled with a T, so we can easily identify this line with an outline in green here. So interior angles, so they are interior. They are non-adjacent, and I'll explain what that means. Remember, that's not next to one another. And on opposite sides.
Can I get a custodian up to the office for just a moment? A custodian, thank you.
And on opposite sides of the transversal. Okay, so let's go ahead and look at that. There's only two in this case. So the first one, remember they're interior, so they could only be these inside angles here. They could not be on the outside. So let's look at the 4, angle 4. What would be the alternate interior angle? So remember, they're on opposite sides of the transversal and they're on inside of the lines. So the opposite of the transversal would be 6 here. So angle 4 would be an alternate interior angle with angle 6. And the other one, and the only other one, would be with angle 3. An alternate interior angle of angle 3 would be here, angle 5. Angle 5. Okay. Moving on to alternate exterior angles. Let's go ahead and identify that. Alternate exterior, I'm going to highlight our alternate exterior angles, and these are exterior angles, so they're on the outside of the two lines. They are non-adjacent, which means they do not belong next to one another, and they are on opposite sides of the transversal. So let's go ahead and look at that. There's really only two pair relationships here. And the first one, they're on the outside, so they have to be exterior. So let's start with number 1. And so if we look at number 1, if it's on the other side of the transversal, that'll be 7. So angle 1 and angle 7. And then the other one, the relationship with angle 2, so then angle 2 and angle 8. Angle 8. Okay, so that would be our alternate exterior. The next one will be consecutive or same side interior angles. Same side interior angles. So consecutive interior angles here. Our interior angles, so on the inside, interior angles.
Mr. Kyle, please meet Miss Joyce in the front office area. Mr. Kyle, thank you.
Interior angles that are on the same side of the transversal. So same side and on the inside. Okay, so let's go ahead and look at that. Let's start with number 4 because it has to be on the inside. So let's identify angle 4 here. And they are going to be same side. So it would be 4 and 5. Remember, our transversal is this T line here. I'm just going to outline that for you. On the same side of the transversal and on the inside angles. So that's going to be angle 4 and angle 5. And then we can do the same for angle 3. The consecutive interior angle for angle 3 would be angle 6 and angle 6. Okay. So So let's look at the last one, consecutive exterior, and you can imagine what that means. Exterior is on the outside, so or the exterior of the angle, and the same side of the transversal. So I'm gonna go ahead and highlight my consecutive exterior angles. Let's identify the transversal, labeled with a T. So I'm gonna draw the line outlining that. And we're going to look at exterior. So our exterior, we could start with angle 1. So the consecutive exterior angle for angle 1 would be angle 1 and angle 8. And for angle 2, it would be angle 2 and angle 7. And that would be our consecutive exterior on the outside. All right, so let's go ahead and look at example 3. Let's try to label all of these. We're gonna name the type of angle relationship, and if no relationship exists, we're just gonna write none. So let's go ahead and look at this. So we are actually looking at 3 different lines and 8 different angles. So let's identify the transversal. Well, in this case, the transversal is labeled with an R. So this is our transversal here because it intersects both lines. And we have created 8 angles. So let's look at angle 1 and angle 8. So angle 1 and angle 8, what would the relationship be between those two? Angle 1 and angle 8. And if you want to pause the video here and try to name these yourself and see how far you can get, I would pause the video and then try to answer A through F and then start it back, and then we can watch what our answers are. So I would recommend you pausing right now, trying this yourself, and then restarting and looking at the answer. All right, so angle 1 and 8 would be alternate exterior. It's on the outside angles, and it's on opposite sides of the transversal. Angles 2 and 3 are on the same side of the transversal and in different positions. They're next to each other, so a consecutive interior. Angle 5 and angle 7, let's look at their relationship. Angle 5 and angle 7 would be corresponding. Angle 2, I'm use a different color here, angle 2 and angle 7. Angle 2 and angle 7 would be alternate interior. Then we have angle 1 and angle 3 would be corresponding as well. And then the last one on F, angle 5 and angle 8 would be consecutive exterior, consecutive exterior. The reason it's consecutive is because it's on the same side of the transversal. The reason it's exterior is because they are on the outside angles. Okay, so that's going to be A through F. Let's go ahead and look at example 4. And example 4 has actually 10 parts instead of just 5. So let's look at name the type of relationships. If no relationship exists, we're going to write none. So this one's a little bit more complicated. So we actually have 2 different lines, and we would identify, we could have this as the transversal between A and B. This could be a transversal between A and B, and then this could be a transversal between D and C, and same here. So we have a lot more building on this one, and we have a lot more angles. So we're actually twice the amount of angles. So we have 1 through 16, and we're going to identify all of them. So let's do our best on this. I would pause the video here and see if you can answer A through E first and see how far you can get, and then restart the video and see if you can get your correct answer. So pause the video, try A through E, and then see if your answers are correct. So I'm not going to highlight because it's going to make this a mess with different colors. So we're just going to look at it and identify it. So 5 and 13 would be corresponding angles. 7 and 14 would be here and here. If we're using this, listen, if we're using this as that transversal, okay? So 7 and 14 would be alternate interior. Three and 6, so our transversal here would actually be this line. So 3 and 6 be alternate exterior. Nine and 14, using this as our transversal. 9 and 14 is consecutive exterior. And then the last one on this page is going to be 4 and 7, using this line as our transversal, 4 and 7, and those are corresponding angles. All right, let's go ahead and look at F through J, the last set on example 4. Go ahead and pause the video here, see if you can answer these and name those angle relationships. Hint, hint, there will be some that are none. So go ahead and try that, pause it here, and then restart it once you're ready to check your answers. So F, 2 and 10. Let's look at 2 and 10 using this line as our transversal for 2 and 10. Those would be listed as corresponding angles. I'm sorry, let's go back. This is not right. 4 and 7 is consecutive interior. I'm sorry. Let's go ahead and fix that. Make sure all of the other ones are correct. That looks good. All right, fix that on E. And then F will be 2 and angle 10, which would be our corresponding angles. On G, 8 and 14, so let's identify 8 and 14 using this as our transversal. 8 and 14, that's consecutive interior. Six and 11, if you'll notice, they're far apart. They don't share a transversal, so they are actually no relationship or none. 4 and 13, same thing. They don't share a transversal here, so that would be no relationship as well, so we would write none. And then 4 and 9, the last one, 4 and 9 here, it would use A as the transversal, and that relationship would be alternate interior, alternate interior. All right, so that sums up 3.1. So make sure you print out those outlines, complete these notes first, and then go ahead and look on OnCourse, and you will see your assignment for 3.1. It's going to be 2 pages. I hope you understand this. If you don't, please feel free to send me an email explaining what you don't really understand and what questions you may have. Okay, so we're going to finish 3.1 with this. If you have questions, feel free to email me. Thank you, guys.